the whole premise of this sort of a calories is a calories idea is that, if you eat 100 calories of cookies and 100 calories of, say, an egg, well, they're going to be equally fattening, okay? But that's garbage. It's not even true in any sense, because the problem is when you take that food, like you take a cookie and put it in your mouth, and you take that egg and you put it in your mouth, the minute you put it in, the hormonal response of our body responds to that food completely differently if it's cookies, like carbohydrates, or egg, which is fat and protein.
Mm-hmm.
Completely different response from a hormonal standpoint. Therefore, the instructions that we are giving to our body from those foods is completely different. So, for example, you eat a cookie, the hormone insulin spikes way up. Okay, and what insulin does is it tells our body to please store body fat. Store those calories as body fat. That's its job. That's insulin's job, is to tell our body to do that. So when you eat the cookie, insulin spikes up, all of that 100 calories goes straight into our fat. You eat that egg, of course, insulin does not spike up nearly as high, and therefore our body can use that energy. They'll use it for different things. They'll use it to build muscle. They'll use it to, burn off, because it's not about the number of calories. Because your body, when the calories goes in, can either store it or it can burn it. But which one it does depends on the instructions that we give our body, which are different according to the different foods. So, when people say a calorie is a calorie, it's like, of course a calorie is a calorie, but I never asked you that question. I never said, is a calorie a calorie? It's like saying a dog is a dog. It's like, so what? That's a nonsensical statement. The question I really want to know is, are all calories equally fattening? And that is not true.
So you take 100 calories of a big gulp. Well, the effect on our body is different. One, it's going to spike insulin. It's going to go into our fat stores. It's going to store that energy, but it's not going to make you full, right? So if you eat an egg or a little piece of meat, it will make you full. So therefore, the effect on the number of calories coming in is totally different. The effect on our bodies, whether we store it or not, is completely different. And therefore, what we have to focus on is not the number of calories, because we know that's a strategy that has failed, like not just once, but it's failed over and over and over and over. What we have to do is concentrate on a strategy that is going to tell our body to use up some of those calories that we've stored, which is just body fat. Right? And there's a number of ways that you can do that. You can change either, really only one of two things. You either change the types of food that you eat, basically the question of what to eat, or you change how often you eat, which is a question of when you eat, right? And that's where intermittent fasting comes up. Because if you simply reduce the number of times you eat in a day, well, that's going to change everything, because by not eating, you're going to let your insulin levels drop. As your insulin levels drop, your body's actually going to pull those calories out of storage and use them, because that's what the body does. I think the best thing to do is use a bit of common sense, and you have to think and you have to look through the test of time. So if something has withstood the test of time, then it's fairly decent advice. Okay, so you look back at the 70s, and I always choose the 70s because this is a time where there's not a lot of there's not widespread hunger in the United States. It's fairly advanced. But there's, at the same time that there's relative availability of food, there's no obesity. And the question is why? Like, what did they do differently then compared to what we're doing now? And of course, the big change came in 1977, which was the change to eat a very low-fat diet, right? So in 1977, the dietary guidelines for Americans came out, and all of a sudden, all of us were told that we should eat less fat. was the equivalent of telling people to eat more refined carbohydrates. So if you look back at the first food pyramid, at the bottom of the pyramid, there's bread and there's rice and there's potatoes, you know, and it's like eat 7 or 8 servings a day sort of thing, right? 7 to 11, I think, servings a day. And it's like, well, who thinks eating 7 slices of white bread a day is slimming? Like, it's not very slimming, because now we look back and say, okay, well, you know, eating a bunch of French fries and potato chips and, you know, bread is not very good. And you can say, well, those are all refined foods as well, but that's what was on the pictures, right? Was the white bread and so on. So you have to say, okay, well, that was one of the big changes that happened. So if we simply go back to a more traditional way of eating, are we going to be able to sort of regain this sort of effortless maintenance of our weight? And you'd have to say, well, that's probably true. So this sort of whole low-fat thing that came out of the 1970s was the big change. Prior to that, of course, people ate fat, they ate cheese, they eat eggs and all this sort of stuff. And it's interesting because, again, if you look at the big scientific data of the time, in the 70s, people ate 3 times a day, breakfast, lunch, and dinner. And by the 2004, when you look at the big surveys, most Americans were eating closer to 6 times a day. So breakfast snack, lunch snack, dinner snack. So again, big changes in both what we ate and when we ate. Now, they were related in some sense. That is, people who are eating a lot of refined carbohydrates, you know, you eat, if you ate steak and eggs in the morning, you're pretty full until lunchtime. If you ate 2 slices of white bread and jam, you're sort of ravenous by 10:30 and looking for a low-fat muffin. So people started eating much more frequently. So the thing is that what I'm talking about mostly is going back to sort of a 1970s style diet, which of course people had been eating all the way prior to that, which is not a low-fat diet, which is basically eating natural foods, eating the fat, like, you know, this whole thing about eating low fat, cutting out the butter and cutting out the cream and stuff, that didn't exist before the 1970s, because people didn't care about that stuff so much. Then you started to hear the advice from dietitians, oh, you should eat 6 small meals a day. It's like, okay, prior to 1970s, nobody ate 6 meals a day. At no time in history did anybody eat 6 times a day, as opposed to eating 3 meals a day, natural foods. And if you want to sort of push it, well, you can skip a meal. Because remember, in the 1970s, if you were a naughty boy, you got sent to your bed without dinner. You basically fasted for 20 hours from noon until breakfast the next day. Yeah. And nobody died. Nobody had any problem, right? It was fine. Yes, you're a little hungry and hopefully you learned your lesson. But that was it. That was it. So if you wanted to lose weight, you could simply change one of these levers and say, you know what, I can fast, because if I don't eat, what's going to happen? Well, my body is going to be forced to use the calories that have been stored, which is body fat. That's perfect. What do you think body fat is there for? It's there for you to use as a source of energy if you have nothing to eat. So if you're fasting, you're basically feeding yourself through your own body fat, which is literally the reason we have body fat. It's not there for looks. It's there for you to use if you have nothing else. So we're just using it for what it's supposed to be used for. And we're giving our bodies the time it needs. And that's what I started working on probably 5 or 6 years ago. And people, boy, they thought I was crazy. But the results we saw were just incredible. Like, people were coming off their medications, they're losing weight, their diabetes was reversing, even early stages of kidney disease were reversing. It was just insane. We actually wrote up a paper and we profiled these 3 people who had about 25 years of type 2 diabetes. And like within a month and a half, we practically had them off. We had them off all their insulin and had all 3 of them off all their medications. And they actually became non-diabetic by the definition of their blood work. And, you know, years later, they're still non-diabetic. So 25 years of type 2 diabetes, like reversed like that in a month. In those diseases of the 20th century, the paradigm of treatment was completely different. That is, if you got sick, you went to the doctor, you had an infection, he says, here, take these antibiotics, go get better. Or you get an appendix, here, I'll do surgery, you go get better. Now you take that paradigm of, here, let me give you a pill, or here, let me do some surgery on you. And now you apply it to a chronic disease like type 2 diabetes. And it doesn't work at all. Or obesity, it doesn't work at all. Because what happens is that there's all these obesity drugs that have failed because you had the same paradigm of, here, let me give you this drug to lose weight, and it doesn't work because you have to actually change the diet. You actually have to change your lifestyle. That's the only way you're going to get better, because these things are not genetic, because we know that they've increased, like type 2 diabetes, increased a lot, but the genetics of the human population have not changed in that period of time. So it's a lifestyle disease. Obesity, same thing, right? It went way up from the 70s on. There's no genetic change. So it's a lifestyle disease.
Mm-hmm.
It's not a drug, a drug deficiency, or it's not something you can just do some surgery on and make better. But you have to change your paradigm and say, in order to get better, we don't need more drugs. We need to get the right information so that we can change our lifestyle. We can change our diet. We can incorporate fasting, for example. And now you can make some progress because you're applying the right paradigm, which is, this is a chronic lifestyle disease. Therefore, I need a chronic lifestyle treatment, right? So before, in the 20th century, it's all, you need this drug. Now it's about, this is a dietary disease. Therefore, you must have a dietary treatment. There's a ton of ways that doctors are influenced to prescribe more medications, even when it's marginally useful. And if you ever speak to a doctor, everything is very familiar. So you see you have these drug reps which will come in and they'll take you to dinner, right? Fancy dinner, and they're not supposed to. There's actually guidelines on this, but they'll take you to the fanciest place ever. I could go to dinner at a fancy restaurant literally 5 times a week if I wanted to, all for free, like literally like $200 meals. For the big pharma, these are not by accident. They know what gives them a return on their investments. And they know, because they actually track every single prescription that I write. So I will write a prescription and I'll send it to the pharmacy, and they buy information from the pharmacy. If I went to some free drug dinner where I got some free thing and they were promoting some blood pressure pill, they could see that immediately my prescription rate of that blood pressure pill compared to another one, which was probably cheaper. The problem is that level of corruption moves all the way up. So then the next thing they do is you get offered a role as a paid speaker. So what they'll do is they'll give me a opportunity to give a talk for other doctors, and they'll pay me. And again, I don't do this, but I could do this if I wanted to. Pay me $1,500 for a couple of hours to enjoy a nice dinner and just talk to some other non-specialist about a drug. And it wasn't any random talk. They would give you the slide deck. So they're like, this is what you're going to say. And unfortunately, a lot of people do that. It's easy money. It's a free dinner, like $200. It's $1,500. And you get to feel like a big shot because you're talking to other doctors, teaching other doctors. Then you get up to the professors and the people in the university. They're not talking a few $100 here and there. They're raking it in from big pharma. So the big pharma companies are sponsoring them. They get these people to do studies where they get millions of dollars, and they get to do these things where they go to like conferences as part of the study. And it'll be like essentially a free trip to like Vienna. They're getting sponsorship for their studies, which is tens of thousands, hundreds of thousands of dollars. And of course, they will advance because the pharma company knows that this doctor is very pliable to all this sort of bribery, which is really what it is. It's basically bribery. So a doctor who advances doesn't advance necessarily because he's very smart, but because he has a lot of people pushing him in the background with this money. Because if you're bringing in money to the university loves that, right? They're always cash strapped. So then all the people who are taking the most money from the pharma companies get pushed up to the top. And then you have things like these trials, the things that we depend on to make decisions, they're all run by the pharmaceutical companies, right? So it's like so let's take antidepressants as an example. So you know that antidepressants, you have to produce a study that show that it works in order for the FDA to approve the drug, which is fine. That's the way science is. But a drug company, they underwrite all the studies. So the thing is that they get to choose which studies they publish and which they don't. So their strategy is to do, say, 40 studies, and 20 of them they'll just throw in the trash. And then they'll publish the other 20. Well, which do you think those 20 are? The 20 that look the best. If you throw out all the trials that don't work and simply count the ones that do work, well, all of a sudden your drug looks great. And this is exactly the story with antidepressants. So the drug looks great, and now you can go spend money promoting it to doctors and say, look at the evidence. The evidence says that this drug is amazing. The journal articles that publish these studies, they get a lot of money from pharmaceuticals. If you ever read studies, there's a huge list of conflicts of interest. So for example, in the sugar industry, what they found, for example, is that, they took all the studies on sugar and they divided that into, the people that got money from the sugar industry, and virtually every study that the people who didn't get any money from the sugar industry found that sugar is not good for you. Smoking and, asbestos and soot and all these chemicals. So those are called carcinogens. And the question is, how do those carcinogens lead to cancer, and what is cancer? Because that's really the question. So of all the sort of major medical diseases, cancer is by far the most mysterious, because we've sort of figured out what causes a lot of disease. So we have infections and we have viruses. We have, if your arteries get blocked up, you get a heart attack or you get a stroke. So we figured it out. We really haven't figured out what is cancer, because cancer is not this extrinsic agent like a virus that comes in and attacks you. It's actually like a perversion of our own cell. So if you have lung cancer, that cancer is derived from your own originally normal lung cell. So what turned that cell, which is normal, like everybody has, and turned it into a cancer cell? And that's the really interesting part, because that's our thinking about that has changed over the years. So we initially thought of it as sort of a fluke, like, it just happens for no reason. It just grows too much. So if it's a lung cancer and it grows too much, well, we're going to devise ways to kill it. So we have surgery, for example, we have radiation, we have chemotherapy, which is drugs. So that's the sort of classic, and that still sort of forms most of what we think about cancer treatments. But really, they're indiscriminate ways of killing people, right? So it's cutting, like surgery, it's burning with radiation, or it's poison, like chemotherapy. As we got into the 2000s, people started to think about genetics more and more. So we, cracked the genetic code, and then we got the Human Genome Project, which, put out all the, the entire genome of a human being. And then we said, okay, well, cancer is a disease where genetic mutations will change. So if you happen to have a chance genetic mutation in a gene that controls growth, well, that can cause you to grow too much. So then we started to look for genetic mutations, and it was initially very successful. And then we thought, well, if we simply look at the cancer, we can find the 2 or 3 genetic mutations, develop these drugs to target these mutations, and there, it's all done, right? And it worked well for the first little bit. So we developed a couple of drugs for breast cancer, for a type of leukemia, fantastically successful. But the problem was that as we started to look further and further into this genetic mutation model, we actually didn't get anywhere, because they didn't have 2 or 3 genetic mutations. They had like hundreds of mutations. So after the Human Genome Project, they did this Cancer Genome Atlas, where they sequenced thousands of cancers to find out what type of mutations there are. And it turns out that if you have one cancer, you might have 100 different genetic mutations, and the person next to you with the exact same cancer would have 100 completely different mutations. So all over the place. It was complete like bedlam. It couldn't make any heads or tails of it. But the important thing from that standpoint is that you can't treat that, because you can't get 100 different drugs for one person and 100 completely different drugs for the next person. It just isn't possible. So that sort of brought that whole genetic paradigm to a grinding halt. And that's where most people think we are, but we've actually gone much further than that. So we've gone the next step and said, well, if genes are mutating, we know they're mutating, what is driving this mutation? And it turns out it's likely an evolutionary process. So it's a response probably to chronic injury. As you get this chronic injury, like tobacco smoke, like radiation, your body starts to go back and the cell becomes more primitive, more like a solitary, like a single-celled organism. That is, our bodies are composed of multiple cells, but we have to work as a team. So your lung has to work with your liver, right? And the liver, all the liver cells have to work in conjunction with blood cells and so on. So it's all a team. So cells have to cooperate with each other. When you get this sort of chronic damage to the cells, you basically lose this law and order. And what you get is like anarchy. So in this anarchy of, the lung or the liver, or wherever you're getting this damage, the certain cells can sort of break off on their own and become like single-celled organism, which is much like, in a city where there's, total chaos, police have gone, you get looting and all this because everybody's looking out for themselves. So instead of cooperating with just these cells actually start to behave more and more like they're out, every cell for itself. And that's when it becomes dangerous because the cells who are out for themselves, they grow, right? Because that's what they want to do. They move all over the place, just like a bacteria will move all over the place. So these cells can metastasize and there's no controls on this growth. So normally we control the growth of the liver very tightly. That is, the liver is a certain size and it won't grow any bigger. That paradigm is very powerful because it leads to sort of the next level in terms of what are treatments, which is now we're talking about immunotherapy, where what we want to do is not just indiscriminately kill, but we want to get, strengthen the immune system, sort of like a police force to go in there and hunt these bad cells, as opposed to indiscriminately killing everything, right? You're not trying to carpet bomb, cells into submission. What you're trying to do with immunotherapy is go in there. One of the things we never realized until about the year 2000 is the very strong link between obesity and type 2 diabetes and cancer. It's a huge risk factor. So when they look at the attributable risk for a certain thing, so they look at, say you take a population and what percent attributable risk factor is. So you say tobacco. Tobacco is about 35%. The diet is about 30 to 35% as well. So it is as big a risk factor to cancer in general as tobacco. Nothing else comes close. Wow. Like not radiation, not anything. So the question is, what part of the diet is it? It's mostly the part that leads to obesity. So it's not all cancers. Like lung cancer, it makes no difference. Tobacco smoke makes a difference to, being obese makes no difference to lung cancer. But breast cancer, colorectal cancer, liver cancer, pancreatic cancer, the World Health Organization identifies 13 cancers as definitely being obesity related. And it's a real issue because as you have this increasing obesity epidemic, what we're seeing is in those cancers that are obesity related, we're seeing an uptick now. And it's affecting younger and younger people because the population that is obese is actually going younger and younger. Like you're seeing kids who never would have, you look at classrooms and there was like 0 obese kids in the 1970s, and now there's a handful. So the problem is that cancer is following them down. So you're getting cancers in younger people because of this obesity epidemic. So if you identify the cause, you do very well. The problem is you can't identify every cause. We don't know what causes breast cancer, for example. We don't know what causes colorectal cancer. But the big advance there is in terms of prevention. That is, if you understand that being overweight is going to increase your risk of breast cancer and colorectal cancer a lot, and that's what's driving these young people to get breast cancer and colorectal cancer. then you can do something about it and try and get them to lose weight. You can also look at the certain genes like the BRCA gene and try and screen for that. And then in terms of colorectal cancer, you have screening for colonoscopies and that kind of thing, where you take out these these lesions before they become cancer. So we're making good progress on all that. In terms of treatment, the treatment has been a lot slower to get to the front lines, but this entire area of immunotherapy is just very, very promising in terms of a different type of treatment, as opposed to the old treatments of sort of cutting, slashing, and burning. And beyond the sort of just the genetic paradigm of cancer, now we have this sort of immune side of cancer that we can start developing new drugs to treat. And in certain instances, they've really done a great job in terms of improving the survival. Certain people with melanoma, for example, and certain types of other cancer have really benefited. We're sort of in the early stages of that development, but I'm hoping that that's a whole new angle, and that's always very promising to get these whole new angles. The best is to prevent it, of course, and that's where understanding of the role of nutrition, the role of obesity, the role of type 2 diabetes in it will hopefully prevent it. Because if you can prevent it comes down to the same thing. If you can prevent the obesity, you're going to lower your risk of breast cancer, colorectal cancer. Then you never have to worry about treatment.